Welcome to next lecture of compiler design. I am Dr. Parul Yadav, assistant professor at the Department of Computer Science and Engineering in Institute of Engineering and Technology. Now today's lecture is on constructing SLR parsing table and parsing. So in previous class we have already talked about LR0 automaton, and here we will have just brief summary of LR0 automata, where we have the augmented grammar, and with the augmented grammar we compute the closure function and goto function, and we use this function to design the LR0 automata. So here the state represent the closure of particular set, and the goto function is used to mark the transitions. So just see how to complete it. Just here we will look at all the grammar symbols, just immediate right to dot. So here immediate right to dot we have E. So here we will mark the transition for grammar symbol E, and while marking the transition will shift in this item, will shift it one to the right of E. So here we will shift it right of E, and then here again we will shift to right of E. So we will get E dot plus T. Now for we will obtain closure of every newly entered item. So this is this one, but after dot here we have nothing, and here we have plus, so nothing more can be added. Now similarly with respect to T, we can mark the transition because here it is reaching us to I2. Similarly with respect to F, if we will shift F to the right, so we will get this particular set of item. Then parenthesis, just see here F2 opening parenthesis, it will shift dot here, then just right to dot is E. So we will add E production, then this is T, then we will add T production, then this is F. So we will add F productions, right. Similarly then suppose at this set I1 we have the cases, if we have the item like E prime to E dot, right. If we have this item in a particular set of item, then it will have the transition for dollar, and it will lead us to accept situation, accept state. So this is the accept part action. Now next is E2, just after dot we have plus, so we can mark the transition for plus. So this is for plus, and just right to plus we have dot T, then we will add T production, then we have F, then we will add F productions, and in that way we can complete this LR0 automata. Now next is we use this automata to construct the parsing table, and here we are focusing on LR0 parsing table. So process is, first we will get C, that is a set of I0, I1 up to In, the collection of set of LR0 items for G prime. So first of all we will obtain collection of LR0 set of items. Now state I is constructed from II. The parsing action for state I are determined as follows. So the actions are, if we will look at the item one by one, right. So suppose we are at II. Now if we in II, if we have A2 alpha dot A beta, where A is a terminal, if A is a terminal, then actually here we are creating a parsing table, and this parsing table will have two main sections. One is corresponding to action, and second is corresponding to goto. So here first we are seeing that what to write with respect to action. So action columns are marked for terminals or dollar, while goto columns are marked for non-terminals. So the thing is, if this A, just right to dot, if this symbol is terminal, then in this table we will go to the cell action I comma A. I mean this I, and A mean the terminal that we have. So in this particular cell, suppose this is the cell that we have, here we will write shift J. J mean with respect to this terminal, to which state, to which set of item are we moving. So this is Ij suppose, so this is J. So here in this particular cell we will write shift J. Now next is, if there is item like A2 alpha dot, mean in this set of item this dot is at extreme right position. Then we will perform the reduce operation. We will write reduce A to alpha, mean in this particular cell mean action I comma A, but here we will write reduce A to alpha. What is I? I is this one. What is A? A is follow of capital A, follow of capital A. So, for every A, we will write reduce A to alpha. Now, if there is item S prime to S dot in II, then we will write action here I and dollar cell, we will write except. So, this is the 3 rules for with respect to action. Now, there are 3 more rules. The go to transition for state I constructed for all non-terminals. So, if we have go to II comma A to Ij, so mean this is the starting state, this is the ending state, and input symbol is A, capital A, where A is a non-terminal. Then in this particular cell go to I comma A, we will write J. Now, these 2 rules are very simple. All entries that are not defined by rule 2 and 3, they are made an error, mean all blank entries will be considered as error. Now, the initial state of parser is the one constructed from the set of items containing S prime to dot S. So, that will be the initial state. So, this is L0. Now, here we will construct the parsing table. What ingredients we require? This is our grammar and this is our LR0 automata, and here we have written 2 outputs first and follow as we discussed in previous class. So, for every grammar symbol we calculated first and follow. Now, what we will do? First we will create a table, and in table we will make the columns for state, action and go to. Right. In state we will look at what are the items over here, how many set of items do we have. So, we have actually I0, I1, I2 up to I11. So, in states we will write 0, 1, 2 up to 11. So, total 12 states are there. Now, next is action. In action here we will write all the terminals in the grammar along with dollar. So, we will create the column for every terminal, 1 and 1 for dollar. Now, in go to what we will do? In go to we will write all the non terminals. Now, here here basically 4 types of actions are there. One is respect to shift, second is with respect to reduce, third is with respect to accept, and last is error. So, we know or blank entries are error and except will be only 1. Now, we will look at with respect to shift and reduce. So, one by one we will see. Now, see here for shift what we have, we will look at the item one by one, and the item just immediate right to dot if we have terminal. If we have terminal, then in this particular cell we will write shift J. Shift J mean this J. So, we will write shift J. Now, see here we will look at I0. Now, at I0 we will look for the item where immediate right to dot we have terminal. So, here immediate right to dot we have terminal here, right. So, due to this terminal opening parenthesis, the next item is I4, right, I4. So, with respect to 0 and opening parenthesis, we will write shift 4, we will write shift and 4, the number corresponding to the item shift 4. Similarly, immediate right to dot, here we have ID, immediate right to dot we have ID. So, with respect to ID we are moving to item I5. So, here in this and this cell we will write S5, shift 5. Similarly, we will look at I1. Now, we will find where we have like here just right to dot we have plus, right. So, with respect to plus we are moving I6. So, 1 and plus, here we will write S shift 6. Now, similarly we can complete all shift entries like I4. If we will go to I2, this is I2. Just after dot we have multiplication. So, 2 and multiplication, and with respect to multiplication we are moving to I7. So, here 2 and multiplication we will write S7, right. Now, we will go to I3, and at I3 this is I3, and with after dot we have no terminal, right. Now, similarly we will go to every set of item and we will find the item where just right to dot there is terminal. Then we will see with respect to terminal to which set of item we are moving. Then in that table with respect to that particular cell we will write shift and the number corresponding to item, that set of item, right. So, in this way we will fill all shift entries into the table. Now, we will focus how to fill all reduce entries into the table. So, reduce के लिए क्या है, whenever we have the item like whenever we have dot at extreme right position, dot at extreme right position. So, we will find those items and then in this particular cell I comma A is what, follow of A. So, in those particular cell we will write reduce using particular production. So, here we will write the production number. So, this is our production 1, then 2, 3, 4, 5, oh sorry, this is 1, 2, this is 3, then this is 4, this is 5 and this is 6, right. So, the numbers that I give on right side, these are the production number. So, after shift we write the state number, state symbol, and after reduce we write the production number. So, now see, suppose we are in this item, just see in this item I2 we dot is at extreme right position. So, we will obtain follow of capital E. What is follow of capital E is it is closing parenthesis and dollar. So, in I2 mean this one I2, and with respect to closing parenthesis and dollar. So, closing parenthesis we will obtain dot is at extreme right. So, we will obtain follow of E, and this is opening parenthesis and dollar. Now, the production is E to T and the number to this is 2. So, here we will write R2, here we will write R2. Now, see the set that has the production like E prime to E dot, E prime to E dot. So, here this is I1. So, with respect to I1 and dollar we will write except, this is with respect to this rule, that is in this is this one go to transition, wait, this one when we have this item then action I comma dollar we will set to accept. So, here we will write the accept. Now, next is the go to. Now, see how to fill the go to. So, for go to we will see go to II comma A and next is IJ, and where, so where A is a non-terminal. So, on the transition we will look for the transitions that are marked for non-terminals. So, we will write A comma in the go to I comma A we will write J number. So, in this table we will look at the items one by one. Suppose I0, in I0 we will see with respect to non-terminals what are the transitions. We have 3 transitions E, T and F, and this is leading us, this is starting from I0. So, we will write with row corresponding to 0, and now for E next set of item is I1. So, for E we will write 1. Now, here for T next is 2. So, here we will write 2. Now, for F name of set of item is I3. So, here we will write 3. Similarly, we can complete all go to entries over here. Now, next is LR parser. So, what the LR parser is doing, the input to LR parser is a grammar and the parser is actually will generate the table. So, it is a table generator, directly from the grammar it will generate the parsing table for us, and then that parsing table will be utilized by LR program. This is a driver routine or LR program, and we will pass the input string to the parser, and that LR program will use the LR parsing and then produce the output. Here for our convenience, as output we will generate the parse tree, but as practical aspect is construct, we do not generate the parse tree explicitly, rather we do as front end, this part does some semantic translations directly. So, in this particular section, this is the LR program which is same for all types of LR parser, whether it is simple LR or canonical LR or LALR, but difference lies in the parsing table. So, this will be different for all three parsers, but the driver routine will remain the same. Now, the broad structure for LR parser, it takes the input string A1, AI, AN and dollar. This is the end of the string marker. Next is the stack that has the state symbols. This is SM, SM minus 1, or here we will have S0. S0 represents the bottom of the stack marker. So, these states are representing some grammar symbol. So, rather than pushing grammar symbols onto the stack, we are pushing the state number. Here we have the LR parsing program, and that LR parsing program uses the parsing table, and parsing table basically has two main function, action and go to. So, based on current input symbol and the symbol that is the state that is at top of the stack, it will use the parsing table and will produce the output. So, this is the broad structure. Now, LR parser will have the configuration like this is the stack contents from bottom to top, S0, S1 up to SM, and this is the input string, the remaining input string that is to be passed. So, this is suppose AI plus 1 up to AN followed by dollar, and this is actually, if we map SM with grammar symbol XM, SM minus 1 with grammar symbol XM minus 1 and so on, this S1 with X1. So, and followed by the remaining input string from AI to AN, this will give us the right sentential form. Right, and S0, this is not representing any grammar symbol, rather this act as a bottom of the stack marker. Now, this is with respect to the behavior of LR parser. LR parser behave for basically it behaves in basically does 4 actions. One is shift, reduce, error and accept. So, we will focus on shift and reduce. Now, see, suppose current input symbol is AI and at top of the stack we have SM. So, this is AI and SM. So, 4 actions are possible. Now, first possibility mean we will look at the table, and in the table mean this is a table. So, here in action there are 4 possibilities: shift, reduce or accept or error. Now, suppose at this particular cell of the table, suppose action is shift S, shift S. Now, what will be changed in LR configuration? So, this is the initial configuration S0, S1 up to SM. So, we will have S0, S1 up to SM, and here we have S. So, it will be shifted onto the stack. Simply we will push S, this number onto the stack. Now, next is this is the AI. So, here we will advance input pointer one cell to right, because S symbol state corresponding to this grammar symbol has been pushed. Right. So, we will advance this input string, now it will point to AI plus 1. So, input pointer will advance one cell to right. Now, it will point to AI plus 1 up to AN and dollar, that will be the remaining input string. Now, next is if we have action SM comma AI, and suppose in this particular cell there is reduce using this particular production, reduce using A to beta. So, there are 3 steps for reduction. First is we will see what is the length of beta. We will calculate what is length of beta, and suppose length of beta is r. So, we will pop r symbols from the stack. So, initial configuration is this, it will pop r symbols from the stack. So, we will get the form Sm minus r, mean it will be S0, S1, S2 up to Sm minus r, because after this r symbols have been popped. So, here we will have Sm minus r. Now, next is, now the exposed state is Sm minus r. Now, we will use the go to field of the table, and in the go to field we will see the go to field corresponding to this state number and this non terminal, and with respect to this we will find some number, and that is suppose S. So, that S will be shifted onto the stack, and there will be no change in input configuration, it will remain the same. So, this is about reduce operation. Now, next is action. Now, suppose in this particular cell mean AI and SM, now action is suppose accept, in that case we will announce successful completion of parsing. Now, next is suppose with respect to this and this, in parsing table we have blank entry that denotes the error, in that case we call an error recovery routine. So, that will handle it. Now, next is SLR parsing algorithm, just to will combine all these constructs. So, let A be the first symbol of WS, mean on the input tape the first symbol is small a. So, while 1, let S be the state on the top of the stack. So, with respect to S and A, we will look into the table. Now, action with respect to S or A, suppose this is shift T. In case of shift T, what we will do? We will push T onto the stack and we will advance input pointer one cell to right. So, if shift operation is there, there will be change in stack as well as input tape. In stack we will push one symbol, and in tape we will advance input pointer one cell to right. Now, second possibility, if action corresponding to S comma A is reduce using A to beta, reduce using A to beta. So, we will do 3 steps. First step is we will calculate length of beta, right, and then we will count how many symbols are there, we will pop these many symbols from the stack. Next, we will see what is the exposed state, and then with respect to exposed state and A, we will refer the go to table, and in go to table we will find the particular, suppose this is T. So, we will push onto the stack T, and then exposed state is T, then we will go to exposed state is T, then we will go to T comma A, and we will find what is the, that is suppose Q. So, we will push Q onto the stack, and then push Q onto the stack, and there will be no change in input tape. Now, next is if this cell we have accept, then we will break, or otherwise we will call then error recovery routine. Now, we will complete this parsing table with respect to now we will do the parsing with respect to this parsing table. So, here we have 0 and this is the input. So, we will see the parsing table with respect to 0 and ID, this is the stack and this is the input string. With respect to 0 and ID, here we have S5. So, here S5 stands for shift. So, for shifting what we will do? We will shift 5 here, and with respect to 5 symbol is ID, and here we will advance input pointer one cell to right. So, this is multiplication ID $. Now, here we will look at 5 and multiplication. 5 and multiplication, this is R6. R6 mean here we will do the numbering 1, 2, 3, 4, 5, 6. So, we know after R, this is the reduce using 6th production. So, here it is what? Reduce by 6 mean F to ID. So, for reduction what we will do? In F to ID, mean F to ID, we will calculate the length. Length is 1, length of right hand side, this is 1. So, we will pop one symbol. Now, exposed state is 0. Now, with respect to 0 and f, we will refer the go to table, this is 3. So, here we will write 3 and the symbol is f, and here there will be no change in input table. Now, next is 3 and multiplication. 3 and multiplication reduce using 4. So, that is reduce by 4 mean T to F. So, here we will pop one symbol, exposed state is 0, with respect to 0 and T we will go to table. So, we will get 2, this is T, and here we will get multiplication ID and dollar. Next is 2 and multiplication, as 7. So, here we can take the decision, this is we need to shift 207. Now, this is T and multiplication, this is ID and dollar, on operation is shift. Now, 7 and ID, shift 5. So, this is 6. So, 0, 2, 7, 5, T multiplication ID, and this is dollar, and this is shift operation. Now, next is 5 and dollar. With respect to 5 and dollar, reduce. So, this is 7. 5 and dollar, reduce using 6. So, this is reduce by F to ID. So, length of ID is 1. So, we will pop one symbol, exposed state is 7, with respect to 7 and F we have 10, and there will be this will be T multiplication F, no change here. Now, with respect to 10 and dollar, this is R3. So, R3 mean reduce by T to T multiplication F. So, here we will pop 3, 0. So, here we will pop 10, 7 and 2. So, here we will get only 0, no 2. Now, exposed state is 2. So, with respect to 2 and T, 2 with respect to 0 and T, we have 2. So, here we will push 2. Now, here we will have T and here dollar, and now this is 2 and dollar, this is R2. So, reduce by E to T. Now, 9th. So, here we will pop 1, this is 2. So, now we will go to 0 and E. So, this is 1, this is E, and this is dollar. Now, we will go to 1 and dollar. So, this is accept. So, this is all about this LR parsing. So, here we have seen how to we have briefed about how to draw LR0 automata, and then how to construct a parsing table, SLR parsing table for the automata, and then a particular input string we have completed the parsing, where we perform some reductions, and the table was able to answer us that should we do reduction or shift operation. And because this string is as per the grammar, then it announces the successful completion of the parsing. So, I hope this is clear to all of you. Thank you so much.